Light from the sun takes 8 minutes to travel through the vacuum of space to reach your eyes. Yet, if I ask you to picture the sun, the image appears in your mind instantly. That feeling of instant thought is a convincing illusion. The reality inside your skull is bound by physical constraints just as rigid as the laws governing the stars. This illustrates the absolute speed limit of the human nervous system. Even along myelinated axons, electrical signals max out at 120 meters per second. Compare that to a beam of light, traveling 2.5 million times faster. Your instantaneous mind is a product of biological scale. To find the source of this delay, we have to look at the points where neurons attempt to communicate with one another. Neurons are separated by a 30 nanometer gap called a synapse. For a signal to bridge this divide, it must stop being an electrical pulse and instead chemically diffuse across the chasm to trigger the next cell. This chemical transition is the ultimate bottleneck. It is roughly 1,000 times slower than the electrical propagation occurring inside the nerve fiber itself. Because of these cumulative delays, the human brain cannot experience reality in real time. Instead, it processes the world in discrete cognitive cycles lasting between 260 and 390 milliseconds. This slow refresh rate forces the brain to discard massive amounts of data. While your senses take in 1 billion bits of information every second, your conscious mind can only resolve about 10 bits in that same window. We live in a low bandwidth, delayed simulation of the present. While our internal processing is throttled by biology, the external universe is governed by the absolute speed of light. When Albert Einstein was 16 years old, he imagined a scenario that challenged the very definition of reality. What would happen if you chased a beam of light? If you could catch it, the light should appear frozen in space. But light cannot be stationary. If it stops moving, it ceases to exist as an electromagnetic wave. Einstein realized that light speed must remain constant for every observer, regardless of their own motion. This meant that if the speed of light wouldn't change, time and space were the only variables left to bend. Imagine you are standing on a railway platform, watching a train speed past. 2 lightning bolts strike the ends of the train. From your stationary perspective, the light from both flashes reaches your eyes at the exact same moment. You see them as simultaneous. But consider a passenger sitting in the middle of that train, moving at near light speed toward the strike at the front. Because the passenger is rushing toward the forward flash, that light has a shorter distance to travel. The front strike hits their eyes first, and they conclude that the 2 bolts did not happen at the same time. This shatters the intuition of a shared universal clock. In a world where light has a finite speed, simultaneity is a biological myth. Now, let's place an observer inside a futuristic spacecraft that suddenly accelerates to 99.99% the speed of light. How do our eyes, evolved to track slow-moving prey, cope with the visual distortions created by the absolute speed of light? The first thing you experience is relativistic aberration. As you plow into the incoming photons, the geometry of space itself appears to shift. Because you are intercepting light rays at extreme velocities, photons from your periphery appear to fold forward. Your field of vision shrinks into a narrow cone. At near light speed, this distortion reaches a physical limit. Light from behind the ship wraps into the forward view, concentrating all visible radiation into a single blinding point ahead. Our biological eyes cannot actually see this spotlight for long. The light ahead is blue shifted into frequencies so high they become lethal, invisible gamma rays, exceeding the detection range of our retinas. To the rear, any remaining light is red shifted into radio waves. Because our biological sensors can't resolve these extreme frequencies, the universe behind the ship simply fades into a pitch-black void. We are chemically bound observers, processing the universe in slow-motion snapshots. Yet the mind has proven faster than its biology, decoding the limits of light to see a reality our eyes were never designed to perceive.